Good morning, good afternoon, good evening, wherever you are at this particular moment. You are welcome to our lesson on coordinate geometry 2, circles. Okay, before you appreciate coordinate geometry 2 and appreciate it well, okay, you should all have done coordinate geometry 1. The one has everything to do with lines, 2 circles. Okay, however, if you haven't done coordinate geometry 1, don't worry. Okay, the basic information that you need, I know you did it in JHS. That's finding the distance between 2 points, the magnitude, okay, of a line joining 2 points, okay, the equation of of a line, the gradient of a line. All those basic information, they are information that you know or you were taught in JHS. So if you haven't done coordinate geometry 1 in SHS, don't worry, we can still do the 2. So however, anything that I say that you don't really understand, please let me know. Okay, nonetheless. Okay, so the main objective for our meeting today, or the objectives for our lesson today, 1 will be you being able to define a circle. You should know what a circle is. Okay, you should know the standard equations of a circle. You should know the general equation of a circle. So by the end of the lesson, you should know all that I have mentioned. And you should be able to form equations given the center and what and the radius. So form equations of a circle given the center and the radius, and we should be able to go backwards, meaning given the equation of a circle, we should be able to find the center and what and the radius. So today's lesson will be centered around these what objectives. So please take note. As you become perfect, then I will introduce you to certain what concepts. Okay, as well. Okay, so quickly, let's see. When we were doing plane geometry 2, I defined what a circle is. Okay, can someone, or I want someone to tell me what's the definition of circle that was given. I remember I asked you individually, okay, what a circle is, and some of you explain circle in your own, okay, terms. Okay, your own understanding. And I told you that in SHS, this is how we would want you to define circles, taking into consideration certain keywords. So any help? I want someone to make me, okay, Irene.
Please, a circle is a locus of points equidistant from a fixed point.
Very good. Okay, so locus of point equidistant from a fixed point. And if you remember, I said every circle should have a radius and a center. Is that not it?
Yes, please.
Okay, very good. So the definition is what we have here. Circle is the locus of point equidistant from a fixed point. And what did I say the name of the fixed point, okay, is?
The center.
The center. Perfect. Okay, that's why you are my professors. All right, so now quickly, in let me quickly, yes, in coordinate geometry 1, okay, lines. When you are asked to find equation of a line, what do you need? What basically do you need to find equation of a line? Hello? If you are asked to give equation of a line, what information do you have to fish for before you can get what the equation of the line?
Is the gradient.
Very good one. So you need the gradient. That is very true. And what else?
Is a point.
And a point. Very good. All right, Irene, I was expecting you to be very active because you were with us when we did coordinate geometry 1 last vacation. Am I right?
Yes, please.
Very good. Okay, we have done it, so don't worry. Okay, so that's why I skipped, but I will send the video to you. Okay, those of you who haven't done it, so don't worry, so that you will watch it and abreast yourself, okay, of the concept that you are supposed to know. So for lines, you need the gradient and what and a point. And for lines too, okay, we were told that equation of a line must be given in a certain form. Okay, one, we said it can come in what we call the standard form. So the standard form of equation of a line will be ax plus by plus c is equal to 0. And we call this one also the general form. And we can have the equation also in what we call the slope intercept form, which is what you have, the y is equal to mx plus c, where m, you know, m is the slope, which is the same as the gradient, and c is what is the intercept, the y-intercept. So this is what we call the gradient or sloped intercept form. This is the standard or the general form. Okay, and we also said you can write your equation in what we call the intercept form. So the intercept form will be x over a plus y over b is equal to what? 1. So where a is your x-intercept, the x-coordinates, okay, of the x-intercept, and b is the y-coordinate of the y-intercept. So like I said, I will send you the video. Only that the point I want you to know, or I'm making, is that, okay, equations of lines will take certain forms, either the general form or the standard form. So with the same concept, we are going to extend it to, okay, the coordinate geometry 2, which will be what? Circles. So straight away, let's go and look at what? The equation of a circle. So you can see equation of a circle, however, I've put in bracket standard. So it means what I'm going to mention here, these are the standard equations that you have to be very conversant with. Okay, we have another one which is what we call the general equation. So that when I mention standard equation, you know exactly what I'm talking about. If I mention general equation, you know the type of equation that I'm referring to. Okay, so for the standard equation, you have one. This is the general standard equation. Okay, so A, equation of a circle with center. So just like lines, when you want to get a line, its equation, you need a gradient and a point. However, for circles, remember I told you circle, its definition depends on the center and the radius. So again, if you want to get the equation of a circle, you will need these two information, which will be the center and the radius. That's the coordinates of the center and the radius. Is my point well made?
Yes, please.
So lines, gradients, and a point. Circles, center, and a radius. If you are able to get these two from any question, you are good to go in terms of you extracting the equation of what? Of a circle. Okay, so in this, you can see that I have the equation of a circle. So A will come to B. That's the special situation. This is the general situation. Equation of a circle with center AB. So meaning the x-coordinate of the center is what? Is A. And the y-coordinate of the center, okay, is B. And radius may be R units. Radius is distance. So every distance should have what? A unit. Okay, so the radius is R and is given by this formula. So coordinate geometry 1, if you remember, those of you who were with us, I told you that the coordinate geometry 1 basically has to do with formulas. You should know your formula and how to use your formula. The same way, 2, you should know your formula and how to use the formula. Okay, so this is the equation of what? The first standard equation of a circle. X minus a all squared plus y minus b all squared is equal to r squared. And this is where this formula is coming from. And the proof will tell you. We all know how to find the distance between 2 points. Is that not it? Okay, so you can see that here, this is what I have. I have a distance, okay, this is my center with the coordinates x1, x sub 1, y sub 1. Okay, and I have a point on the circumference of the circle. Okay, and that point, once it's a point, it should have x coordinates, y coordinates. So let me call this s sub 2, y sub 2. So if I'm looking at the distance here, okay, the distance between my center and what the point on the circumference. Okay, you know, distance formula is given by what? Usually we'll say that root of what? Change in x squared, okay, plus what? Change in y squared. Am I right?
Yes, please.
That's our
Yes, please.
distance formula. Okay, so if you extend your distance formula to this, change in x, you know, usually you don't write this, you write this one. Okay, though this is the simple meaning, but in terms of you doing your computation, this is what you write. So it will be your second point, x coordinates. So change in your x coordinates, which will give you x sub 2 minus x sub 1 all squared. So that's the change in x. And the change in the y coordinates too is what we have here. And this is equal to d. But you can see that the distance here, any distance from the center to the circumference is the same as what?
The radius.
The radius. So
Radius.
now here, I change the distance here, d, to what? R, and haven't done anything special because you know that d is equal to r. Is my point well made?
Yes.
Yes,
And
please.
again, remember I said in what I have here, I said my center is A, B. So the x coordinate is A and the y coordinate is B. So I change the x sub 1, y sub 1 here, which is the general one, indirectly to A, B. So now my center I'm using, instead of x sub 1, y sub 1, I'm using what? AB. And my point here too, instead of x sub 2, y sub 2, I'm using xy. Here we were using x values, so to distinguish between them, that's the more reason why you see the sub, because if I had a circle drawn this way, okay, and let's say my center, I call the center, obviously will have x coordinates, y coordinates. So if I call the center x, y, the coordinates, and I come and pick a point here, also x, what, y, you see that there will be conflict. Okay, once I call the 2 point, the coordinate xy, it's like I'm assuming they have the same x coordinate, they have the same y coordinate. You get the point?
Yes, please.
So that's why we had to distinguish between the 2 points, okay, by using the subs. So x sub 1, y sub 1, x sub 2, y sub 2, for you to know that these 2 points are not what? The same. And again, now, because I'm not, okay, dealing with what? X for my center, it means this now can take my x and y, the usual x coordinates and y coordinates. So it can now, so my any point that I pick now can now take xy. Here I couldn't use xy because, okay, if I use xy for the center and I use xy for any point, you know what will happen. I've explained that. So I have changed this coordinate to this and the coordinate of the center to AB and the distance also to R. So if I extend this one, the distance formula, I know my D is R. So it means my R will be equal to root of the change in x, and it will be x minus a. That's what I have here, squared. Then plus change in y will give me y minus b squared. Please, are you following? Are you all with me?
Yes, please.
Very good. Now you can see that if I square both sides, what do I get? This one will be squared. The square root, it will take care of the square root that you have there. So if I square both sides, I'm going to get the whole of this one squared, okay, and it's equal to this one squared. But you can see that the square will get rid of the square roots there. So the square root will go. So I'll be left with what is under the square root, which is this. And it's equal to r squared. And this is where the formula, you can see that this is exactly the same as what we have here. So this is where the formula is coming from. So anytime you are asked to, okay, get the equation of what? Of a circle with its center given and the radius, quote this formula, come and substitute the coordinates of what? The x, okay, I mean the center, the x coordinates and the y coordinates, okay, which will take the a and b respectively, and substitute your r here. Expand, combine like terms, and simplify, okay, as far as possible. So we'll get there. So here the point is, know this formula, and I will help you, okay, or guide you as to how to use this formula. So you now know that this formula is a valid formula. So in case you forget or you are asked to prove, this is how you prove it. In some books, they will use the Pythagoras theorem, but you should know that the distance formula comes from the Pythagoras theorem. Am I right? So indirectly, what we have done here, okay, we made use of what Uncle Pythagoras theorem. So please, okay, take notes of what we have here. And I said this is for the general. Okay, now let's look at the specific, okay, or a special situation, that is B. So if the center of the equation is the origin, okay, and the radius is R, you should know center being the origin means the center is what? What will be the coordinate of the center?
0.
0, 0. So take note. So it means here I'm going to deal with what? 0, 0. Okay, so if you have your center to be 0, the special situation, that's the 0, 0, your origin. Okay, instead of quoting the general one, which is this, you have to quote this one. If you come and quote this, you are not wrong, only that it will be a waste of time. You quoting the formula alone will take your time. I will quote this, and you can see that you write more in this compared to this. So the person who knows that if the center is the origin, this is the formula that you quote. This is a special situation. So it means the other one, you quote it when the center is not the origin. Is my point well made?
Yes, please.
And you can see that if the center is the origin, then we know, okay, so prove. If the center is the origin, then it means A is equal to what? 0. Am I right?
Yes, please.
Okay, and B is also equal to
0.
0. So this is what if you substitute that one into the general, okay, one. That is the general standard formula. Okay, x minus 0, you know, is x. So this will give you x squared. Plus y minus 0 is y, which will give you y squared. And it's equal to r squared. You see the validity of what we have there. Okay, and that is what you have here. So you can see that with this one, this is x. Changing x will give you, okay, changing x, your distance here, okay, which is your r. Your r squared will be equal to your changing x, okay, squared. And changing x here will be x minus 0. That is x squared that you have here. And your changing y will be y minus the y coordinate 0. So that will give you y squared as well. And it's equal to r squared. So it's the same explanation. Okay, so please take note. My point here is, if the question gives you the center other than the origin and the radius, if you want to start quoting the formula, okay, and using the formula, carrying out your substitution to get whatever equation that we are looking for, you quote the first one, which is the A. However, if the center is the special one, which is the origin, then you have to quote the second one, which is the x squared plus y squared is equal to r squared. That's a special situation. So special, okay, center, which is the origin, demands a special formula, and that's the formula that we have here. Okay, any questions at this point?
No, please.
Okay, so we are fine. Okay, so quickly, let me see. All right, okay, so now let's go and look at our first worked example. So we are asked to find the equation of a circle with the following center and what and radius respectively. So it means if you look at this, A, this is your center and this is the radius. B, the center radius. C, center radius. D, center radius. And E, center radius. Is that clear?
Yes, please.
Okay, very good. So let's go and look at how best we can, okay, use the formula that was just thrown at you to find the equation of what? Of a circle. Okay, so with the center and the radius given. Okay, so let's look at the solution. If you look at the information that you were given, 1A, okay, you were given, like I always said, extract. So don't write given 1, 2. Okay, and root of 6. You have to be precise in your extraction anytime you are extracting. Okay, the 1, 2, what is it? We know it is the center. And the root of 6, what is it? It is what? Our radius. So that's how come my extraction was that. So given center 1, 2, and radius r, okay, root of what? 6. Is that clear?
Yes, please.
Okay, so now this is what we are going to do. Any question, okay, in math, like that's what I tell my student. Any question that you need a formula, okay, to proceed, please, after extracting the information needed in the question, the first thing you write is the formula. Okay, write the formula and let the formula guide you as to what to do. So in this case, you come and write equation. You were asked to find the equation of what? Of a circle. So you write equation, okay, is given by, and here let's see, it's our center special. It's our center special.
Yes.
Did you say yes? Remember I said the special center is which one?
When the origin is given.
When it is the origin. So if it's not the origin, then it's not a special center. So once it's not a special center, we'll quote the formula for A. So you write x minus A all squared, okay, plus y minus B all squared is equal to r squared. Is my point well made?
Yes, please.
Okay, so here I am going to write, but when you mature, what I'm writing here is not necessary. You can just go and substitute directly. So, but, okay, my A is equal to, you know, this is AB, your center. Is that clear? So your A will be equal to 1. Your B is equal to what? 2. Okay, and indirectly, you've stated your R there. Is that clear?
Yes.
If you didn't write radius r and you just wrote radius is equal to root of 6, then you have to come and add, and r is equal to root of 6. Is that clear?
Yes, please.
However, if you write it like the way I have here, then you can choose not to add this, because that information is equally here. Then this command becomes end. Is that clear?
Yes.
Okay, so now it's just a matter what you have there. Every formula is a relation. It will always have equal to. So when you are carrying out your substitution, you use implication. You cannot use equal to. So it will be x minus 1 squared, okay, plus what? Y minus what? 2 squared, and it's equal to root of 6, okay, squared. Point well made.
Yes, please.
Okay, so now this is what we are going to do. You cannot leave your equation to contain brackets. You can't leave your equation to contain fractions. And you cannot leave your equation, okay, in its unsimplified word form. So it means your final equation should be devoid of fractions, should be devoid of what? Brackets, and equally it should be in a simplified form. So it means if the equation can be reduced, you reduce. Is that clear? Okay,
Yes,
very
please.
good. Now, if you remember in Form 1, okay, you were taught how to expand, okay, a binomial squared. That if you have A plus B squared, all squared, you were told that this will be equal to what? The identity will be what? A squared, plus, help me.
Plus 2b squared.
No,
Plus 2b.
No.
Plus 2ab.
2AB, very good. Then plus
B squared.
B squared. And if you have A minus B all squared, this will be equal to
A squared. Minus 2ab.
Minus 2AB, very good. Then plus what? B squared. Okay, so here, once you are mature, that's why we taught you this. So you don't come and write x minus 1 multiplying x before you expand. You should know how to expand this without breaking this one down. Is that clear? So if you go
Yes,
by
please.
that, then it means I'm going to get x squared minus twice the product of this and this. So this time, this x times 1 will give you s. Twice that will give you 2x. Am I right? Then plus 1 squared and 1 squared is 1. Is that clear?
Yes,
Yes.
please.
Then plus, we come and do same here. It will give us y squared minus, okay, twice the product of this. So the product of 2 and y will give you 2y. Twice that will give us 4y. Is that clear?
Yes, please.
Then plus 2 squared, which you know is 4. And that will be equal to root of 6 squared, which is 6. Afa.
Yes, please.
Okay, so at this point, this is what you do. You can obviously see like terms here. Okay, and equally. So your equation, this is the form. Okay, that it should take. You should have no fraction, no brackets, simplified, and you should have everything on one side equated to 0. Every standard, every general equation, you should have everything on one side equated towards 0. Okay, that's why anytime you define an equation, linear equation, you see that it will be as plus by is equal to 0. Okay, that's linear equation in 2 variables, and maybe somebody can write plus c. Okay, quadratic equation as squared plus, okay, bs plus c is equal to 0. You get it? So everything must be on one side equated to 0 anytime you are talking of a general or standard equation. So in this case, what do we do? This is all that you are supposed to do. Come and write your the square term first. So s squared, then plus what? Y squared. So your square term, it is the s term that must be written first, then followed by the y, okay, term. Okay, then you move on to the linear term, and the linear term too, it will be the same thing. Your s term, which is 2x here, followed by your y term, which is what? The 4y minus 4y. Is that clear? Then you can see the 1 and the 4 here you can add, and that will give you plus 5. That is equal to 6. Is that clear?
Yes.
But remember, we said in the equation, everything is supposed to be on one side equated to 0. So it means I have to bring this one to this side, and this side will be 0. So if I do that, I'm going to get s squared plus what? Y squared minus 2x minus 4y. Then I will get 5 minus 6, which will give me minus 1 is equal to 0. Is that clear?
Yes.
Yes, please.
So I then draw my conclusion. You can move a step further before you draw your conclusion, or because it will be a repetition, you draw your conclusion here. Therefore, this is the equation. Is that clear?
Yes, please.
However, please take note, okay? You can choose not to add this. Is the equation. Once you have equal to 0, this is an equation. So even if you don't add this English, you are done. There is nothing wrong. If the teacher marks you down, you can call your lawyer on the teacher. All right, okay. So I guess my point is well made in the first example that we have here.
Yes, please.
Very good. So quickly, we are going to look at the second one. Okay, so B, again, we are giving the center the radius. Okay, so let's see. Okay, let me clear this so that I will deal with it the other way. Okay, quickly, let me do this. Okay, so clear this so that, okay, center is equal to, okay, and radius, let me use equal to, giving center is equal to, okay, so that's what we have there. And radius is equal to, if you like. I don't want to use the letters. Someone equally can be smart. I will give you another way of presenting your solution without writing the but, what have you. Okay, so this is the second one. So the first one, you realize I introduced R. Okay, in the second one, I haven't introduced R. So it means my but will still come in. Okay, so let's go. All right, so in this case, this is what we are going to do. Okay, so now I am going to proceed this way. So let's go. Okay, so what do we write? Okay, as usual, we are supposed to write solution. Okay, and that is up there. Then the question number, Okay, or B, then you extract the information. The question gave you a center and a radius. Okay, the center special.
No, please.
Okay, so it means we have to go and quote. So you write equation is given by. Okay, so help me quote the formula.
X minus A squared
Okay, squared, the whole class.
plus Y
plus
minus B
y
squared
minus b squared equals r.
is
Equal
equal
to
to
R.
R squared.
R
Very
squared.
good. Okay, so you can see the formula. Okay, in the formula, I need A, I need B, I need R. Okay, so where can I get my A? Okay, so my A is remember I said the center is AB. Okay, so here I know I'll come and write but. Okay, my A is the x coordinate of the center, and that is 1. Okay, B is the y coordinate of the center, and that is -3. And my R is the radius, which is 2. Is that clear? So at this point, I come and write this implies not equal to, because where I am going to carry out the substitution is a relation. So I can't write equal to. So what do I write? It will be x minus 1 all squared, okay, plus y, help me. It will be minus 3. Is that not it?
Yes, please.
Which will give us plus 3. We are mature, so squared. We won't write minus 3. We know. Okay, then it's equal to r squared, and r is what? 2. So you get 2 squared. All correct?
Yes, please.
Okay, so now you know expansion, simplification. Okay, so this means I'm going to get s squared. Help me expand this.
X
Minus
squared
2.
minus 2x
Mhm.
plus 1.
Plus 1. Okay, then help me expand this one too.
Y squared
Mhm.
minus
No,
3y
no. If the
Minus
sign here is
3
plus,
plus
if the sign
3y.
here is
Sorry, sorry.
plus, okay, your second term should also be plus. So plus
6y.
6y plus
9.
9. Very good. It's equal to
4.
4. As simple as that. At this point, you are in a very comfortable lead. So remember the terms with the highest degree, followed by, okay, so in that order. So s squared plus y squared, okay, minus 2x, okay, plus 6y. You know, I'm going to do everything mentally. This plus this will give me 10. Then I will bring this one here, which will give me 10 minus 4. So that will give me plus 6. Okay, it's equal to 0. Is that clear?
Yes, please.
Okay, so at this point, I can draw my conclusion. Therefore, okay, this is the equation. And like I said, you can choose not to write is the equation here, because this indeed is an equation. Alpha.
Yes.
Very good. All right. Okay, so now let's see the third question, the C. Any question before we move on to the C? Are we all on board? Have I left anyone behind? Okay, has anyone been left behind? Okay, so you are all with me. Great. We thank God. All right. Okay, so
That
yes, please.
please, you were saying that when we are writing the like we're coming to start the solution, we start with like the given center and the radius. You were saying that we can decide not to add the r at the beginning, but
Yes.
then when we continued, we brought an r.
Which one? Let me, so that I'll be in sync with you.
Like the beginning, we didn't bring the r when we were stating the radius,
So
but
yes.
then when we were solving, we brought the r.
Okay, so this is it. I said, okay, maybe you didn't get my point well. Okay, I said here the center is 1, -3. Okay, you can write, you know, R will always represent your radius. Is that not it? So I can write maybe radius r, because the formula will involve a, b, and r together with your x and y. Is that clear? So I can choose to write
Yes.
comma r. And if I write comma r, then it means I have defined my r in the formula. So if I code the formula, r is already stated here. So when I'm writing the BAT, I don't have to write the r because it's already stated up here that r is 2.
Okay.
You get my point. However, if
Yes,
you don't
please.
state it here, then you have to come and write it, okay, this way. And like I was saying, somebody equally, I can choose to, okay, I can choose to take the step out. If the step would be totally out, then I can write giving center. I know that my center will always be AB. So I can write giving center AB, okay, is equal to this. Then radius comma r is equal to this. In that case, I don't have to come and write a is equal to this b because I've stated my a here, my b here. You get it?
Yes, please.
So you have two ways of going about what you have here. You can choose to extract the information there directly. The information gave you the coordinates with no letters, okay, and the radius with no letters. But per experience, you know that the center is always AB. So you can write giving center AB to be equal to this, giving radius R to be equal to this. Then you quote the formula and you carry out the substitution straight away without writing this. Because what you have here is stated in your giving. You get the point?
Yes, please.
So my point is, don't repeat. So if you wrote AB here, R here, don't come and write but AB. It's just repetition because this information is still up here. So don't repeat to waste your time. Unless that information is not up there, that's where you are supposed to write it. But if it's already up there, don't rewrite it.
Okay.
Okay,
Thank
all
you.
right, good. Okay, so I like it when you ask questions. Okay, obviously, it will give me an indication that your solution, okay, will be better. So at this point, let's see the center. Is the center the special one?
Yes.
Okay, so here you can see center is this, and my radius, I have defined R here. So it means anywhere that I see R in the formula, you've already stated that R is this. So I don't have to go and write but. Okay, Christian.
Please, how do you determine whether it's a special or not? I didn't get it.
Okay, so I said, okay, the standard formula. Okay, in actual fact, you have one standard formula. Okay, which is the x minus a squared, okay, plus b, sorry, y minus b squared, then is equal to r squared. Is that clear?
Yes, sir.
That's the standard formula. However, okay, center can also be the origin. So if your center is the origin, then it means the special one. Origin is always the special center.
Which is 0.
The origin, a center is a point. So a center, every point is supposed to have x coordinates and y coordinates. You get it, Christian?
Yeah.
So it's not necessarily 0, but in terms of letters, we use very soon, maybe the next question. Okay, I would ask you a question there. So if I say it here, it's like I've shot myself in the foot. So only that I want you to know that center is a point, and every point must have x coordinates and y coordinate. Do you agree?
Yes, sir.
Okay, so the center is not 0. Center is not a value. Center is a point. And points are represented by capital letters. Am I right?
Yes, sir.
Okay, very soon you know the special, okay, letter, okay, for this special, okay, point, which is the center. So you might not necessarily directly see the center here. Okay, 0, 0. Sometimes you can write, okay, let's see the question. The question gave us 0, 0. Sometimes it can be center the origin. And you should know that the origin is the same as what 0, 0. Is that not it?
Yes, sir.
Okay, and it's only the special one that has the special name origin. Okay, any other point, it doesn't have any special name.
Oh, yes, please.
You get it? So now you know how special it is. Okay,
Yes, sir.
very good. Okay, so great. Now that we know that the center is the special one, the origin, do we have to go and quote the first one?
No, please.
No, you can quote, only that you end up getting the same result as we, okay, who would think before writing. Okay, we'll get, and we will save time and space. So in this case, you write equation, okay, is given by, so which one do we quote? S squared plus y squared, which is the second one, is equal to r squared. Is that clear? Hello, are you with me?
Yes,
Yes,
please.
please.
Very good. Okay, so if that's the case, then it means now we are, okay, in a very comfortable lead. You only need your r. As for the a and b, it doesn't come in here. Remember, in the, because it you get x minus 0, y minus 0, all of them, each one squared, okay, which will give you this. So you only, for the special situation, you only need your r to substitute. But the r here, you have defined your r. So if you didn't write, okay, r is equal, then you just wrote radius is equal to root of, then you come and write but r is equal to 2 before you carry out your substitution. I hope I'm clear now. I'm clear now.
Yes, please.
Okay, so now I'll come and write, because I'm going to do my substitution. I'll write, this implies that I will have what? My x squared plus y squared is equal to what? My root of 2, okay, squared. Okay, which gives me, okay, s squared plus y squared is equal to what? Is equal to 2. But remember, we said in the equation, you should have everything on one side equated to 0. So you are left with one step. The last step, and the last step, you can draw your conclusion as well. So therefore, s squared plus y squared, then I'll bring the 2 to the side. So minus 2 is equal to 0 is the equation. Afa?
Yes.
Okay, very good. Okay, so we thank God you are all with me at this point. Any question before I move on to, okay, the next one? Any question?
No, please.
Okay, all right. Now let's see. Okay, the D. Okay, you can see here, given, so your D, you see, is this 0? How do you see this?
Letter O.
Yeah, it's O. Look at the 0 here and the 0 there. And also this is O and 5. So you can see that it's like this time around, your center has been given as a point. And okay, the only special point that we have is O. And O is for what? The origin. Do you agree? So in coordinate geometry, unless otherwise stated, anytime you use the point O, it is referring to the origin. Am I clear? So
Yes,
O
please.
for origin. Okay, now we know. So indirectly here, I'm going to extract. So I won't write given O. I know the O here is a point, which is the origin and which is the center. So I write giving the center. I won't write giving the center O. I write giving the center because I need the center to be in a point form, not in the letter form. You get it? So that is how I extracted it. So giving center, okay, O, which is what? I mean, sorry, 0, 0. Okay, which is what? The origin, and radius R again. Okay, so once I know that my center is what is the origin, okay, then I am good to go with my special. So again, I come and write, okay, equation is given by, it involves a formula. So I will quote the formula. I hope you are following.
Yes, please.
So x squared plus y squared. Okay, again, I have a special center. So now I go and substitute. I know my r. So this implies that I'm going to get x squared plus y squared is equal to what? 5 squared. Okay, which gives me x squared plus y squared is equal to 25. But you know, everything must be on one side equated to 0. So x squared plus y squared minus 25 is equal to 0. I can draw my conclusion here. I'm done. Is that clear?
Yes.
Very
Yes.
good. So at this point, okay, I am going to leave this with you to try before we go and look at our next set of questions. Okay, so please do it. Okay, I'm giving you maximum 2 minutes, okay, to finish this. And when you are done, we come back and look at the solution together. If you get it right, okay, you pat yourself at the back. If not, you correct yourself, then you redeem yourself in the next example or the next assignment. Is that clear?
Yes.
Very good. Okay, welcome back. Are you done?
Yes, please.
Okay,
Yes.
so let's see. We are going to do it together, but let me. Christian, what did you get?
Yeah, please, I had x squared, x squared plus y squared plus 2x plus 10y plus 6 is equal to 0.
Okay, please. Did you get anything different? The rest of you?
No, please.
No,
Okay.
please.
Okay, who had a different result? Okay, so as usual, I know some of you will hide. So quickly, let's go and quote the formula together and continue with the solution. So what do we write? We write what the equation is given by having extracted the information. So solution is what you write first. Take note. Okay, equation is given by. Okay, and with this one, it's not special. So we quote our usual, okay, the a, which is the x minus a squared. Okay, then y minus b squared is equal to r squared. So that's what he said. Okay, and all of you agreed that was your answer. So now, in this case, okay, I write but. Okay, and even as you mature, the A and B, you can go and substitute directly without even writing the but. So you are matured. So at this point, I will write, this implies that I can come and write maybe in pencil, okay, my AB. So that indirectly you've stated your A and B. So you go and do your substitution. So x minus A, and it will be minus minus, so it will be plus 1 squared plus y minus B minus minus, so plus 5, okay, squared is equal to 2 roots of what? 5, okay, squared. So here I'm going to expand x squared plus 2x plus 1. Okay, plus y squared plus 10y plus 25 is equal to, this will give me 2 squared, which is 4, into root of 5 squared, which is 5. So in effect, I'm going to get x squared plus y squared plus 2x plus 10y. Then this will give me 1 plus 20. 5 will give me 26, but this will give me 20, so it will be 26 minus 20, and that will give me 6. So indeed, those of you who had this, you are right. So you pat yourself at the back. Well done. Is that clear? Please, are you all with me?
Yes, please.
Great. Okay, so now let's look at our next set of questions. Okay, question will not always be direct, as you saw in the first question, the first worked example, set of worked example, where you were told this is the center, this is the radius. Now, okay, I'm going to read question 2a. You tell me precisely the information that the question has given you. Okay, so find the equation of the locus of points. Okay, that is always root of 2 units from the point 1 over 2, 2. The x coordinates, okay, is 1 over 2 and the y coordinate is 2. What information is given here? Any okay, read through the question and try to see if you can pick what root of 2 is represented, what 1 over 2 is represented. Okay, Gloria.
Please, the root 2 is representing the radius,
Uh-huh.
and point the point is representing
The center. Please, do you all agree?
Yes, please.
Okay, so what we have here, okay, is giving you the center and this is the radius. So immediately you see unit, at least you should know that we are talking of distance. So obviously this will be by this one. And we said it is from this point. And you know that the radius will always be that equidistance. And the equal distance is what you've been told here. So here the information came in the statement form. So when you are extracting, you will not extract it in the statement form. So indirectly you can see this. So giving center and radius. Okay, so this is what you have. But here, obviously, you can see, let me clear the radius. I've not been fair to. So again, so radius, okay, that's what you have there. So now, okay, what do? We have our center, it's our center special.
No, please.
Okay, so again, let me see if I can write center is equal to, so that it will be consistent with what I have there. Okay, it doesn't really matter. You can choose not to write your equal to there. Okay, it implies only that I just want us to be consistent. That's all. So please take note. All right. Okay, so let's go. So at this point, because your center is not special, we go and quote the standard one, the general one that we know, which is, okay, equation is given by okay, and that will give us x minus a all squared, okay, plus what? Y minus b all squared is equal to r squared. Okay, we've done our 1r. Okay, so please let's hold on. Let's pause. Okay, have a water break, our usual water break. By 7:06, okay, we should all be back. Okay, and we'll continue. All right, okay, so now that we've stated, welcome back. Okay, sorry, now that we've stated the equation, the general equation, its formula, okay, we need to go and substitute our A, our B, and our R. You know that your A is this, your B is this, and your R is this, so just go and substitute. So it means indirectly, that step where you have but this is equal to, you are matured, you can take it out and go and carry out your substitution. Is that clear? Okay, so now what do we have? We are going to carry out our substitution. So we will get what this implies. Okay, that we are going to get, okay, x minus 1 over 2 squared, okay, plus y minus 2 squared, okay, is equal to root of 2, okay, squared. All right, so here, the only difference, okay, is that this time round your x coordinate is not that pretty. But don't worry, you can still work with it. We are expecting expanded binomials squared. Binomial squared. So here, this is what we are going to do. You know, as always, to give you your s squared, okay, then we'll get what? Twice the product of this and this. So the product of this and this will give you x over 2. Do you agree? X times half will give you s over 2, or half x. Are you with me?
Yes, please.
But times 2. So if you have half x, okay, half of what? X. Then you multiply it by 2, so times 2. You know that the 2 will cancel, so we end up getting X, so it will be minus X. Is that clear? Should I come again, or my point is well made?
Please come again.
Okay, so remember we said it will be minus 2AB, but it will be minus 2. Your A is what? Your A is X. Your B is half. So if you do that, this 2 will cancel this, so you'll be left with minus X. Can you see?
Yes, please.
So you can always do it mentally. It will be this times this, then times 2. So X is, because you said twice the product of this and this. So the product of this and this is what? Half X. So half X times 2. The 2 in the numerator will cancel the 2 in the denominator. So you'll be left with X. So minus X. But that's not all. Then plus 1 over 2 squared, and that will give you 1 over 4. Afa?
Yes, please.
Okay, then plus, please, if it's not okay with you, let me know. This one is our usual comfort zone, no fraction. So y squared minus twice the product of this, which will give us 4y. Okay, then plus 4. Okay, it's equal to root of 2 squared, which is 2. Are we all fine? Okay, so
Yes,
here, this is what we are going to do. Okay, we are going to more or less rearrange, okay, and collect like terms. But before rearrangement, this is what I want you to do. Anytime you see a fraction in your equation, remember your final equation cannot contain a fraction. So immediately you see a fraction, clear the fraction. Just as we saw brackets here, and we know our final equation cannot contain brackets, so we have to remove the brackets by expanding. Here, after expansion, it contains another, okay, issue, which is what? A fraction. Okay, because we said the equation should be devoid of fraction. So you can rearrange, combine like terms, and clear the fraction later, or clear the fraction, rearrange, and combine like terms. Is that clear?
Yes, please.
So I am going to clear the fraction. So it means I have to, the LCM will be 4. I have to multiply each of the terms by 4. And because one side contains more than a term, okay, you don't have to show your multiplication necessarily show. So you can multiply mentally. Remember I told you if you have a term here on each side, only a monomial on each side, that's where you have to show the division or show your multiplication. Other than that, you don't show. So in this case, what do we get? We get 4x squared, forgive me. Okay, minus 4x. Okay, plus, if you multiply this one by 4, the 4 will cancel. So it will be 1. Plus, this one by 4 will give us 4y squared. This one by 4 will give us minus 16y. This one by 4 will give us plus 16. And it's equal to what? Okay, 2 times 4, which is 8. All correct?
Yes.
Okay, so now that we've cleared the fraction, okay, we'll go back to our usual one. Rearrange, okay, in terms of the degrees, ascending powers. Sorry, descending powers. Okay, then you combine like terms. So I'll get 4x squared plus 4y squared, okay, minus 4x minus 16y. Okay, then this one will give you 16. Okay, plus 1, that will give you 17. 17 minus 8, that will give us what? Plus 9. Am I right? And that will be equal to 0. Okay, so here, but for the 9 here, we could have reduced. But here, because we don't have a common factor, okay, you cannot reduce. All your factors for will be common to only your first 4 terms, but not this. But for you to reduce, it should be common to all the terms. So here it means this is how far you can go. So you can draw your conclusion here. Is that clear?
Yes.
Great. Okay, you are doing well. Okay, keep it up. All right. So now let's look at the next one. Oops. The next one, all our coordinates, the x coordinate, the y coordinate, both of them are not pretty. Okay, so, but still, we can work with them. Only that will tell us that, okay, more work will be done. A little more will be done because we have to clear the fraction. That will be the additional, okay, step. Okay, the rest there were no fractions to be cleared. So now let's see. Again, we quote the formula. Equation is given by and we quote x minus a all squared minus plus what y minus b also all squared is equal to your r squared. So now what do? We can go and carry out substitution. So this implies that, okay, you get x minus a. A is minus, so it will be minus minus, which is plus squared. Then plus y minus b. So it will be minus 1 over 2. Okay, squared is equal to your r, which is 4. Okay, squared. Afa.
Yes, please.
Okay, very good. So at this point, we are more than good to go. We know how to expand when it involves fraction as well. So this will give us s squared. Then it will be twice the product of this and this. So it will be plus first, plus twice the product of this and this. When this is plus, your second term, the sign before it will also be plus. So plus twice the product of this and this. So the product of this and this, like I said, will give you, okay, half what x, or x on 2, then times 2. The 2 will cancel. If you can't do it mentally, go and do it as your rough work. So it will be, okay, twice the product of what x, then what half. Okay, so this will cancel and be left with x, so you write it there. Then the other one will give you 1 over 2 squared. Okay, and that will give you 1 squared, which is 1, then 2 squared, which is 4. So that will give you plus 1 over 4. Okay, but you can always do it mentally, you are matured. Okay, so y squared, this one minus twice the product of this. So this one will give you minus y, then plus 1 over 4. Then it's equal to 16. Afa. Hello?
Mr. Hartman, please, why is the second 1 over 4 positive?
Second, this one.
No, please, the other one.
This one.
Yes.
Yes, so anytime you expand a binomial squared, your first term and your last terms will be positive. It is your second term that will depend on the sign here. So remember we said a minus b, or let me start with the plus, squared is equal to a squared plus what? 2ab plus b squared. And a minus b squared, we said equally will give her the identity is a squared minus 2ab plus b squared. There's an identity that you should know. In the two identities, both the first term and the last term, which will be the square terms, will be positive. It is the middle term that will be positive or negative. That will change signs. Okay, but it will be positive, okay, when the sign here is positive. It will be negative when the sign here is negative. So your first terms, your last term, all of them should be positive.
Okay.
Okay, so please take notes. So you can see that here, because this was positive, my second term, which is twice the product of this, positive. This is negative, so my second term will be negative. So it will be negative twice the product of this and this. Okay, then your last term will always be plus this 1 squared. It was plus the half. So your b here is this. Your a is this. So your b is half. Your a is this. So half squared will give you plus half squared, which is 1 over 4. Clear? Okay, so now what do? We have to go and clear the fraction. Okay, so in clearing the fraction, what are we going to get? We are going to get what? Hey, help me. We are going to get, the SCM will be 4, so you multiply each one by 4, each of the terms. But I've told you, more than a term on one side, so it means you can do it mentally. So 4x squared plus 4x, okay, 1 over 4 times 4 will give you 1. Then plus what? 4y squared, because y squared times 4 minus 4y, 1 over 4 times 4 will give you 1. It's equal to 16 times 4 will give us 32. Hope I'm right. Hello, is my point well made?
So, please, where do you get the
Mr.
32
Please,
from?
it's not 32.
So it's what? So it means you are alive, and you
Please,
are not,
it's 64.
and you are not minding me. So it means you are alive.
Please,
Okay, so
it's
please respond.
64.
Hey, I know how
It's
to get you. It's 64. I know it's 64. Don't worry. Okay, I know it's 64. So you are with me. So 64. Okay, because times 2 that will give you 32. So it will be 64. So please take note. All right. Okay. So now that I know you are with me, let's go. I need your response. So at this point, we are going to rearrange and combine like terms and move everything to one side. So 4x squared, okay, plus what? 4y squared. Okay, then it will be now plus your 4x, okay, minus 4y. Then you get 1 plus 1, which is 2. Then you move this one to the side. So you are going to get what? 2 minus 64, which will give us minus 62. And that will be equal to 0. Is that clear?
Yes.
So at this point, like I said, the next thing that you are going to write, which is your conclusion, is exactly the same thing. So you avoid repetition. So you can put your therefore here. You are done. Any questions at this point? Okay, so even the B, I didn't read the question that we went to solve it. It was a little different from the nature. Okay, it's a little different from what you have. They said, find the equation of the locus of a point moving so that it is 4 units from the point. So again, this is the center. Okay, and this is what the radius. And the locus of, okay, points, okay, moving from equidistance from a fixed point is always a circle. So if you are asked to find the equation of the locus, then it means you are asked to find the equation of the circle. Is that clear?
Yes, please.
Yep.
Very good. Okay, so if that's the case, then I will leave the C for you to do. So let's look at the C. So as for the C, you are doing it right now and you send it to me. So it's a classwork. Is that clear?
Yes.
Okay, so the C here is a classwork. We'll look at the solution together. So do the C and let me see. All right. Okay, so well done. You should have submitted your work by now. So welcome back. Now let's see our next question. So the next question, this is what we have. Okay, so find the equation of the circle with center and passes through the origin. Okay, who can tell me the information that you have? I want someone to tell me the information that you have, okay, provided there. Obviously, one of them is clear. The other I know is also clear. So let's see. This question, okay, the direct information. Let's go. I'm waiting. How do you understand this question? Do you have the basic information that we need directly, which is the center and the radius? Hello, my professors, are you with me?
Yes.
Okay, so I'm waiting for your response. I'm waiting for your response. Or you are still thinking through? Hello? Okay, so always, this is the point. Anytime a question is given, try to picture the situation. And in coordinate geometry, be it 1 or 2, okay, if it is 1, You know, anytime a question is given, the basic information that you need to write the equation of a line is the gradient and what? And the point. So any other information given, take it to this, your comfort zone. Gradient, okay, or point, or gradient and point. If not, then you look at the best way to go. So here, if you look at the question, the information that you've been given here, so let me see. Okay, the information that you've been given here, you've been given, okay, the center. So it's like I have a circle. Okay, its center is given and the center is 4, 3. Do you agree?
Yes, please.
And we are also told that this circle passes through a certain point, which is the origin. So you've been given another point, okay, but at this point, this time around, you are told the point lies on the circle or at the circumference of the circle, which is the same as the circle passing through. Is that clear? It's just like if I tell you that a line passes through a point, okay, A, is the same as the point A lies on the line. Am I right?
Yes, please.
Okay, so this is the origin, and the origin you know is 0, 0. So this is the information that you've been given. But you know, okay, that if you want to extract the equation of a circle, you need the center and what? And the radius. Is that not it? So far, okay, that's how you can easily extract the equation. But one of your major information, which is the center, is given. The other is not given, okay, directly. I should add, but it is given indirectly. Because if I know the center and I know a point on the circumference, I know that my radius will be from here to here. And the radius will be the distance joining the two of the line joining the 2 points. So it will be the distance between the 2 points. Is that clear?
Yes, please.
Okay, so at this point we can go and look at. So you can see that, okay, unlike the first 2 sets of questions, where the first one, it was very direct, center, radius. The second one, it wasn't very direct, but you were given again, indirectly, you were given the center and the radius. But here you were given 2 points, one being the center and the other being the origin. So you know one of your major information, which is the center, directly is given. But the other information, which is the radius, is not given directly, but indirectly is given. And I said you can get it directly by finding the distance between the 2 points. Am I clear?
Yes.
So don't be in a hurry. Study the question and please take note. Anytime the question in terms of circles, coordinate geometry 2, the question doesn't give you directly the radius and the center, go and draw the picture, because marks will always be given for the diagram, because we know that the diagram will be key, okay, in getting, okay, your concepts and getting the solution right. So in this case, my diagram I'm going to draw, but now because of constraints, usually we'll ask you to draw your diagram here, your main work area. Now because of the constrained nature of your papers, okay, now your area that you are supposed to present your solution, we advise that come and draw it as a rough work. But though it's rough work, but please take note, it's rough work, but you don't draw with what? Your free hand. I'm going to draw with my free hand, but don't draw with your free hand. You cannot. So you draw it with appropriate instrument. So I have my circle. Okay, the center is given, and the center is given as what? So I'm extracting. So giving, okay, center. Okay, what was the center? Is it
4, 3.
4, 3? Very good. So center is equal to 4, 3. It's a point. And, okay, points, okay, on the circle. And points, okay, on the circle. That is the origin, and that is what? 0, 0. Is that clear? So indirectly, that's the information I'm going to, okay, have here. So my center is what? Is 4, 3. Okay, anywhere will give me my 0, 0. Afa. So again, I know I'm supposed to quote the formula after extracting the information. Remember I said quote the formula. So the formula says, okay, equation is given by, so you come and write, equation is given by, is our center special?
No.
So it means we have to quote the first one. So x minus a all squared, okay, plus y minus b all squared, then is equal to what? R squared. Is that clear?
Yes, please.
You know your A, you know your B, but unfortunately you don't know R directly. But we can go and find R. So I'm going to write but my R will be equal to the distance between these 2 points. Is that clear?
Yes.
So we know the distance formula. So it will be root of what? Okay, I'm going to do maybe 4 minus 0 squared, or somebody can do 0 minus 4. Then plus what? 3 minus 0, okay, squared. All correct?
Yes, please.
It doesn't really
Yes.
matter. If the person does, if you do 0, okay, minus this, then it means this one you have to do 0 minus that. Okay, the same thing. You will deal with negative squares, but you end up getting the same result. So if I continue, my next line, I write close to the margin. Take note. So that will give me root of 4 squared, okay, plus what? 3 squared. Okay, which will give me root of what? 16 plus what? 9. Which will give me root of what? 25. Which gives me what? 5. But because it's R and I'm finding it, I have to attach units. Is that clear?
Yes, please.
So don't forget. So now you know your R. Once you know your R, you knew your A and B. So now you come and write. This implies you go and carry out a substitution. So you get x minus A. Your A is the 4 squared. Okay, plus what? Y minus B. B is 3. So squared is equal to your R, which is 5. Okay, squared. So at this point, you should be able to proceed. So I'm going to continue here, assuming I have a constraint page. Okay, so now I will continue. I have space here. So that will give me, help me expand s squared
X squared minus 8x
minus 8x plus
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 16
16. Okay, then plus, now let's expand this.
plus y
y
squared
squared
minus
minus
6y
6y
This is y
plus
for
9.
okay, plus 9 is
plus
equal
9.
to what? 25. So we are in a very comfortable lead. Here it doesn't contain any fraction. So rearrange, combine like terms, move everything to one side. So x squared plus y squared. Okay, then minus 8x. Okay, minus 6y. Then the constant we get 16 plus 9, and that will give us
25.
okay, so it will be minus 25, so that will go. So it will be equal to 0. Safa.
Yes.
So you draw your conclusion at this point, therefore, you can put your therefore here. So you are done. All correct?
Yes.
Okay, so now, okay, indirectly, we know how to find the equation of a circle given the center and the radius. Then equation of a circle given a center and a point on a circle. You get it? Okay, all right. So now let's go and look at what? The B.
That complete.
He said I should come again.
I'm writing the.
Okay, you were writing the solution. Okay, all right. Okay, so this is what. So sometimes it's better you capture. Okay, so that you write it later. I will send it to you anyway.
Yes, I'm done.
Okay, good. All right, so that will cover more. We have to finish. This possibly will be the last topic that we'll handle and handle fully. Okay, the others I will send the videos for you to watch. Then we'll do the discussion. Okay, for us to cover more. Okay, so now let's look at the B. Find the equation of the circle which passes through negative 1, 2 with center, or whose center, so don't worry. With center, so it shouldn't be, if I write with, then this should be off. With center 3, 2. Is that clear?
Yes.
Okay, so again, we know a point on the circle and we know the center of the circle. Okay, so what do? We are going to, look at the solution and extract. So given, obviously we will extract the center first. So given center, and the center is equal to negative 1, 2. Am I right?
No, please.
Okay, I'm not right. Oh, the center is
Yes.
3, 2. Okay, so
Yes.
please take notes. The other one, the negative 1 was the point, on the circle. So it was 3, 2. Very good. Okay, and, point on the circle. Okay, and that is what? My negative 1, 2. I hope I'm correct now. But
Yes.
remember, this information is not directly about the center and also the radius. So we have to come and sketch. And don't sketch with your free hand, I've told you. Okay, so as well, you can even use a coin or any rounded shape if you don't have your compass, your pair of compass. So my center is what? 3, 2. Okay, my point on the circle, is what? Negative 1, 2. Okay, so I quote the formula and the formula will tell me what to do. The formula I know now, if the center is not the special one, will be equation is given by, so we quote x minus a all squared plus y minus b all squared is equal to r squared. Okay, so we need our AB, that's the center, the coordinates of the center. Okay, I know A to be 3, B to be 2, so I'm good to go. R, do I have R directly given? No, but indirectly I can go and find R. So I will come and write, but my R, which is the radius, will be equal to, the distance between the 2 points, my center point and the points at the circumference. So that will give me, 3 minus 1, so it will be 3 plus 1 squared. Or if you like, you do minus 1 minus 3 all squared. Is that clear?
Yes, please.
Then plus, I will do 2 minus 2 also all squared. So in effect, I'm going to get, I move to my next line, I write close to the margin. Take note of those. Those of you who have not been doing that. So that will be equal to root of 4 squared. Okay, then plus 0 squared. So that will give me root of 4 squared, which is what? 4. So I will get 4 units. Is that clear? Okay, so now I am going to have, this implies I know my R, I know my AB. So I'll substitute x minus A. A is what? 3. Okay, squared. Okay, and plus y minus B. B is what? 2. Okay, squared. Okay, and is equal to your R squared. R is 4. So 4 squared. So now our expansion, help me expand. Hello? Are you there?
Minus
S squared
minus
minus
6x
6x
plus 9.
plus
plus
9
9. Okay, plus, let's expand this.
y
Y
squared
squared
is minus
minus
2y
4y
plus
plus
2.
4.
Okay, it's equal to this one squared, which is what? 16. So now no fraction. So you thank God, you just have to rearrange and move everything to one side. So x squared plus y squared, minus 6x, minus 4y. Then this will give you 9, plus 4 will give you 13. 13 minus 16 will give us minus 3. And that is equal to 0. Afa. So you draw your conclusion here. Safa.
Yes.
Very good. Okay, so I am going to leave you with the C. So again, this is going to be a classwork. Okay, now I have observed that look at the number. If I give about 19 of us, so 18. Okay, so 19, that is including me. Okay, so 18 students I have here. Okay, so I expect 18 submission of assignments. Please take notes. Usually, if I give it to you as homework, okay, some of you don't submit, and for whatever reason, I don't know. Okay, please, I'm encouraging you submit. That will be the only way that I can measure your level of understanding. So here, I am going to leave you with the C. Do the C and submit. Okay, by 8 o'clock is a class work. Is that clear?
Yes, please.
Okay, so I'll capture and put it on the platform. Those of you who didn't submit the first one, no issue. Okay, no issue for now. Okay, but the second one, please submit. And I know if you're able to do the second one, you should be able to do the first one. So please take note. So that will be it for our lesson today. But before I end the class, as always, okay, the next lesson we are going to look at, now we know how to find the equation given the center and the radius. The next one we'll look at how to find the center and the radius given the equation. So we'll go back. Okay, but I have to make sure this one you really understand before we can do that. And my plan was to, okay, get to this, and we are there. Okay, so anyway, someone said, Samuela, were you the one who said you've done this?
Yes, please.
Have you learned anything new?
I've worked more examples.
Okay, you've solved more examples. What about the way that you are supposed to go about your presentation?
Yes.
Okay, all right. Okay, so now the rest of you, what new have you learned today? Hello? Anything new?
Starkman.
Gloria?
Please, I learned how to find the radius using the center and the point.
Okay, very good. All right. And therefore, you use it to find your equation. Okay. All right. Any other?
Mr. Hackman.
Juanita?
Please, I also learned that when you are given a center and a point, you have to draw the diagram, the circle.
Very good. It's very critical. Usually, marks will be awarded there. At least B1. Okay, 1 mark will be there. So, you know, the little marks that you lose, it will be the marks that will move you away from our required grade, which is the A1. So cherish every mark. Okay, however, what do you call it? Little. Cherish it. All right, okay, then the last person. Hello, last person. Wow, so apart from these three, none of you. Okay, so let me see. Jessica. Jessica, are you there? Okay, Cooks, are you there?
Yes, please.
Okay, so what new have you learned today?
Please, I learned that with when you are finding the equation and the question involves the origin, you use it's special, so you use the straightforward equation,
The special one.
the special equation.
Okay, very good. So basically today, okay, we learned two formulas and how to use them. Okay, but the two formulas that we have there, which will be the x minus a all squared, okay, plus y minus b all squared is equal to r squared, where a, b will be the coordinates of the center, okay, and r will be the radius. And the other one, we said s squared plus y squared is equal to what? R squared. That one is the one that is special. These two, okay, formulas that we have, the equations, are called the standard equations of what? Of circles, or of a circle. One is special and is generated from the general one. Okay, so that's all that we learn. These two formulas and how to make use of them. And because the formula or the formulas involve the center and the radius, before you can use it, you have to equally know or get what the center and what and the radius. You carry out your substitution, expand, rearrange, but make sure that everything is on one side equated to 0. Your equation, final equation, shouldn't contain fraction. It shouldn't contain brackets. As simple as that. Okay, so on this note, thank you very much. Okay, so bye-bye. Yes, please.
This I wanted to ask that the diagram, should we draw it on the side of the
Yes, you're rough.
solution?
The way I presented mine, that's where it's supposed to be. This is a rough work, but you can see that I didn't cancel this. And you should have it drawn at the extreme end, or okay, where it will not interfere with your main work. You can see that here it's almost interfered. So you draw it at the extreme corner, okay, or extreme, okay, side, so that it doesn't interfere with your main work. But there's a vital rough work. Any other rough work is cancelled, but vital rough work is not cancelled. That doesn't mean if you cancel this one, we'll back you down. That's why we said even the rough work, the other one, which is not vital, if you cancel, you still have to cancel in such a way that we can still read what is there. So that if in case there are any marks, we'll see it and give you the marks. Is that clear?
Yes.
Okay, so on this note, any other question? If you don't have any question, then hello.
Mr. Mom,
Yes, hello.
please can you decide? Please, I have a question.
Okay, go ahead.
Please, the center and then the points, can you decide to name them, let's say x1, y1, x2, or
You can, only that you can see that you are matured. So here, once you know your coordinates, even when, if I had taught you the plane coordinate geometry 1, and you are finding the distance, okay, you can write it this way without writing, changing x, because this what you have here has the formula in there. Can you see?
yes, please.
Okay, only that you have quoted the formula with values, but the person who quotes first of all quote the formula with variables. So as you mature, you move from the variables to the values. So the marks that you would have gotten when you quote with the variables, we'll give it to you here as well. You won't lose anything. Only that if you are not mature, then you can't do it mentally like we've done it here. Then the only option left is to quote it so that you know how to do your direct substitution and play it safe. But if you are matured, you can do this and you won't lose any marks. Okay. Any other question? Okay, so we are all fine. Okay, so I think this time round, finally, I'm saying, okay, bye-bye. Have a wonderful day, a wonderful week. Okay.